Alright, so this is the second MATLAB tutorial. We're going to cover visualization. More specifically, we're going to focus on plots and animations. Both of these are very powerful tools, especially within engineering, right? We have a ton of data. It helps a lot to be able to properly visualize it, whether that be on a static plot or a dynamic plot. There's not going to be much here, right? This is just the basics. But we're going to cover 2D functions, we're going to plot lines, and we're going to cover 3D plots. Sorry, these should say plots. And we're going to cover like three-dimensional lines, or a line in 3D space, as well as surfaces in 3D space. And we're also going to look at a bit of animations. The animations will be exclusively 2D, just because 3D animations are a little annoying and my computer's not that powerful. The two that we're going to look at are point animations, where we have a point tracing a curve, and line animations, where we have MATLAB drawing out the line, drawing out the curve as it's, as it comes to it. Once again, nothing too complicated, just some basic stuff. So let's see. Okay, I already have the MATLAB script up here and running. We're just going to go through it one section at a time, right? So we have our start part. This is just pretty standard. For a 2D line, as you know, we need an x and a y. So our x, we defined it as a matrix that goes from 0 to 10 at 1/100th of an increment. And we have y, which is going to be defined by this function that we've created, xy function. And we're going to feed in x1 and we're going to get x, or we're going to feed in x1, we're going to get y1 out of it. So where is this x function defined? Clearly it's not defined in our folder. Well, thanks to MATLAB, we can actually just define the functions at the bottom, which is what at the end of our code, which is what this does here. And as you can see, the xy function simply takes in x and returns the sign of that function. So as we'd expect, the x is just going to be a constant from 0 to 10. It's going to be like a straight line from 0 to 10, and y is going to be sine of all of these values. Please note, these are discrete values. This is not a continuous function, right? So if I said if you ask this MATLAB function, if you ask MATLAB here, what is sine of 0.001, it wouldn't have an answer, because we didn't store it. Then again, discrete values, they are stupendously powerful, simply because sometimes we don't need that level of accuracy. Maybe our function only needs this amount of accuracy. And then we just have, a typical plot function, right? This is a 2D plot function. We give it x, we give it y. We can set the limits very easily, right? The x will go from 0 to 10, y goes from -1 to 1. And this hold on function, we will get to it later, but it allows us to manipulate the same plot multiple times, right? So to run this code, you may notice that this is a chunk of code, which is, when we have two comments like this, we can create a chunk of code. And to run this, we simply click inside of it and we press Control Enter. And as you can see, we have this function, the sine function, right? Pretty typical, right? Somewhere around pi, it goes through the first cycle, right? Somewhere around 2 pi, right here-ish, it goes back to 0. Pretty expected, nothing out of the ordinary. And yeah, pretty clean function. Obviously, we can go left and right, but there's not much to see here. This function only goes from 0 to 10. It's not infinite. So let's move this off to the side real quick, and let's look at the next thing. So the next thing is a 2D point animation. So we're going to plot a point, and because of the hold on function, this point right here with the first data point, right? We're referencing the first index of x1 and the first index of y1, and we're going to make it so this is a bit of syntax stuff, right? The marker size is going to be 5, so it's going to be a little thicker than before. And this OR basically tells MATLAB what the function, what the point will look like. And here it's going to be a red O, right? It's going to be the shape of an O. It's going to be red. And we're only plotting the first point. Then we're going to wait 5 seconds, right? This is so I can click it. And then we're going to iterate through the length of this, and we're going to set the data of this point to be the index that we are at, right? So we'll start at 1, obviously, and we'll set the point data to be the first index. Once it goes through the loop, it'll wait a little bit, it'll pause for 10 milliseconds, and then it'll go to the next point, x1, 2, x1 3, x1 4, all the way until we're done. I may have lied a little there. It doesn't actually go at increments of 1. That runs a little too slow for my computer. So instead, we're jumping at increments of 5. So it'll be, instead of going at 0.01, it'll go at 0.05. And as expected, it'll go 5 times faster. Finally, we have this hold off function. This is just to, spare my computer a little bit of the animation stuff, the computationally heavy stuff. But if we shift enter and then open our plot, we can see that the first point has already been drawn, and there it is. It's being animated. Obviously, if you go inside of it, it takes a little bit of time, right? MATLAB has to process it. But if we click outside of it when we run it, we can see that it will, it'll run a bit smoother. Let's run that again. Shift enter, and we open it, and we see that this time the rest of the graph has disappeared, and it's being a little weird. Okay, so this is actually a very interesting thing, and the reason why is because of this hold off, right? It created a new figure, and it's trying to plot on that figure where we haven't really defined it. So let me once again open this plot, and then we run this. So the first point's been created, and now when we leave the thing, we can see that it runs much smoother, right? Yeah, okay. Pretty typical stuff. The last thing we're going to do is we're going to animate the line, right? We're going to have it draw the line out. MATLAB actually has a function called animated line where we create the handle for this animated line, define our axes, and then we simply add points, right? Once again, it's discrete, so we can just add points at some regular interval and it will draw in between. This draw now function is basically telling MATLAB, okay, draw the figure right now, and then cycle through the loop. If we were to run this, we can see that it runs the line. Once again, if we try to go into the graph, it'll take slower, but we can see that it's updating the line. And once it's done, we update the value. We can see the values in our workspace. And once again, if we zoom in, oops, there we go. If we really zoom in, right, we will see that this is a discrete graph, right? Right. Sine is not a, or sorry, I guess it's a bit tricky to see it here, but if we were to change the time step, you'd see really quickly that this is in fact a discrete graph, right? It's not continuous. I don't know why we can't see it right now, but actually I guess it makes sense, right? These are all, if you look at the intervals, we can see like, oh, there it is. See? We can see that this is not what a sine function does. Obviously a sine function would be a lot smoother, but these are the intervals, right? The intervals go from 0.1, so we can see the intervals here being a bit bleh, right? Alright, pretty typical stuff, easy visualization. Next up we have a 3D line, right? So now we're defining a new x variable and a y variable, as well as a new z. We're going to have our x go from 0 to 10 as before. Our y is also going to go from 0 to 10. And our function is it's called the xyz function. Right? So scroll down again, xyz function. We feed it an x, y, and it'll compute the sum of sines, right? So that's what these x, y, and z values will be. And plot 3 simply tells MATLAB, okay, plot this on a 3D figure because, this is a 3D function. We have grid on so we can see the grid lines. This helps because, 3D, we're looking at a 3D graph, but we only have a 2-dimensional screen. So having the grid lines can help you see, a few details. Rotate 3D on, this is just to, help us scroll around and look at the actual plot and the lines. So we press Control Enter. We see that, this is as expected, right? If we go to just the XY plane, right? So this is X, this is Y. We see that they both go from 0 to 10, and this is to be expected, right? This is a top view of our graph. However, to see the sine, we have to go down a little. And to be expected, right? We expect this, right? We're at pi over 2, right here we expect a peak. And both functions are added on top of each other. So instead of being peaked at 1, it's being peaked at 1 plus the other one, and it'll peak at 2. Same thing. No, pretty typical. And this rotate function helps us, visualize, how the function is in 3D space. Something I wondered about, but I don't know if anyone else is going to think about it, is, how do we change the color of these lines? Once again, there's way too many details for me to cover in any one video, but if you're ever interested, you can definitely just do help plot 3, and MATLAB will gladly tell you, all the stuff you can do with plot 3, right? It's a three-dimensional analog of plot, XYZ, matrices, etc., etc. Parametrically defined things can also happen here, right? And if we click on documentation for plot 3, it opens up the official documentation that MATLAB has. And from here we can go down to name value, right? And this is what this is where we can input arguments, right? Input arguments lets us see what can we do. So we have control over the x, we have control over y, we have control over z. Line spec, this is what you would use if you wanted to change your lines, right? If you want to have a solid line, dashed line, dotted, dot dash, circle, plus sign, asterisk, whatever. Colors, you can even change those. Target axes, this is something that's, which plot do you want to plot this on? You can change the color, you can change the line width, right? Marker size, marker edge. You can input your color as an RGB matrix, although you have to scale it by 155. Yeah, so definitely consult the documentation. We have grid. This is something that I looked into just now, actually. This grid on function, right? We have to leave our grid on so we can, make sense of our 3D plot. I don't think rotate 3D is going to be down here, but similar things will happen if you search up rotate 3D. Right? I use this right now just before I made the video to make sure that I can do it. And so these guys go through a little bit of extra syntax, but you can use just rotate 3D on, and this lets you rotate the plot. Right? Pretty simple. Very useful stuff. So finally, this was a 3D line. Now let's say we want to plot a 3D surface. So how do we do this? Well, we'd have to create a mesh grid. And to put it simply, a mesh grid basically takes in all possible values, right? So here we defined x as going from 0 to 10, and y is going from 0 to 10. But these two are correlated to one another, right? So x and y are linked to each other. So when x is 0, y is also 0. When x is 10, y is also 10. With the mesh grid function, what it does is it actually creates all the individual points in between, right? So we're going to let our x go from 0 to 10. We're also going to let our y go from 0 to 10. And we're going to save these coordinates here. Finally, we create a z surface. And the z surface is, once again, it's a function, right? We can see our function down here. It'll be the same function as before, right? However, the difference is that here we were only feeding it in a line. Right? We were feeding it individual x's and y's. Here we're going to feed in a ton of coordinates and get a whole surface plot. Right? Very subtle difference, but it is there. And finally, we're going to create a new figure, and we're going to mesh. We're going to create the mesh that is this thing. So for every 4 points on the mesh grid, it will plot them, and it will plot them in 3D space. Finally, this color map thing. This is just something I like to do. Once again, I like colors, so I like to see. Once again, so let's go to the XY. So this is the X and Y. Sorry, it's a bit rotated. There we go. So X is going from 0 to 10. Y is also going from 0 to 10. And you can see the individual meshes created in here, right? This point is moving discretely, right? It's not going into every value in between. And finally, we can see the Z, right? So as before, we have where our line originally was, going from 0 to 10. But this time, we also have everything in between, right? This is a mesh grid. This is a surface, not just a line. For the color map stuff, this is just something I like to do. But let me move MATLAB to the side. Move this here. So color map is just, what colors they should use when they're doing it. So if we do color map, say summer, you can see that a bit more of a summer, warmer theme, right? Color map, I believe jet was one of them. Yeah, jet was one of them. So this would be useful as well. It's very, very pretty in my opinion, and it makes the graphs all the better. From this is just my perspective, but I think these look great. But like I said, my favorite is color map winter, and there's plenty more, right? Once again, you can just use the help function to find whatever you need, and that's it. That's the basics of visualization, at least in terms of 2D and 3D plots. And with that, this tutorial is done, and I will end it now.